Often in algebra, an equation will relate two or more different variables to one another. In an effort to better understand the nature of that relationship between the variables that the equation suggests, it's often helpful to solve that equation to isolate one of the variables by itself. This technique is called solving for a variable in terms of the other variables, and it's what we'll look at in this example. It's important to remember that the usual rules for solving an equation still apply. Namely, that if we know which variable is of interest to us, in this example we're instructed to solve for r, so r is our goal variable, then we should try to get that variable by itself on one side of the equation. But because we have more than one variable in this equation to begin with, we should expect that our answer, unlike when we're solving an equation with a single variable, is likely to be a formula. In other words, an equation which has the value of our goal variable on one side and one or more other variables on the other side of that equation. So that's what our answer should look like once we've gotten the r by itself. Beyond that, the rules remain the same. First, identify which variable is our goal. In this example, that's r. And if that variable exists on both sides of the equation, use subtraction to get all the instances of that variable onto one side. If I choose, as I did here, to subtract the r which is on the right-hand side from both sides of the equation, then we'll have no longer any r's on the right-hand side, and we'll have an expression on the left that's a little bit complex. So let's simplify it completely before we go any further. Simplifying the expression on the left involves removing the parentheses by distributing the multiplication by 4 across the addition of r plus s inside the parentheses. That will give us the expression 4r plus 4s minus r. The 4r and the minus r are like terms because they have the same variable factor, r. We can combine those like terms by adding their coefficients, 4 plus negative 1, to get 3. So after simplifying the expression on the left-hand side, we end up with 3r plus 4s. Our equation is now made up of two completely simplified expressions, one on the left, 3r plus 4s, the other on the right, minus s. Now our job is to finish getting the r by itself. To do that, just like in solving any other kind of equation, we'll reverse the order of operations. First, looking for any addition or subtraction that we can do to both sides of the equation to remove some of the arithmetic that's surrounding our goal variable r. Here, if I subtract 4s from both sides, then my left-hand side will no longer have any s's. My right-hand side will be the expression minus s minus 4s, which is like terms that I can combine into negative 1 minus 4 or negative 5s. And now all of our addition and subtraction opportunities are gone. So, to finish getting the r by itself, we need to remove the 3, which is attached to it by multiplication. To remove that 3, we therefore have to divide by 3 on the left and the right-hand sides. Dividing the right-hand side by 3 gives me the expression negative 5s over 3, which I won't bother to simplify any further. If there were any parentheses remaining in the problem at this stage, we would deal with those by beginning on the outside of them and moving to the inside of them. Again, the opposite of what we do in the traditional order of operations when we evaluate expressions. Here there were no parentheses, so we didn't have that step to worry about. Finally, we realize that the r that we were looking for, our goal variable, is now by itself on one side of this equation. That means that we're done. And importantly, the other side of that equation is not, as we might have expected if the equation had a single variable, a number. Instead, the right-hand side is an expression that has other variables in it. In this example, that other variable is s. So to solve for a variable in terms of other variables, first realize that the solution that you'll end up getting will likely be a variable expression rather than a number. But beyond that, all the rest of the rules for solving equations in algebra apply. If there are multiple instances of the variable, use subtraction to get all the instances of that variable onto one side. After that, you can reverse the order of operations in order to isolate that variable by itself, looking for opportunities first to add or subtract, then to multiply or divide. Once the variable has been isolated on one side by itself, The other side, even though it's likely to be a variable expression, will be part of your final answer.